So in the previous lecture, we have discussed about the architecture and the main components of Docker, like Docker client, Docker daemon, image, container, and registry as just an overview. And we have understood what is Docker client and how it works actually, and also Docker daemon, which is a brain of the entire Docker system. So now let us understand what is Docker image and how exactly it works, and also the step by step, and also the internal system, how it works with the file system of Linux operating system or any operating system on which you installed Docker. So how do we define a Docker image? A Docker image is a read only. So we should remember that it is a read only and lightweight template, right? So it is a read only that defines what a container will contain. So it may include operating system, it may include libraries, and also application code. So whatever you define in a Docker file, it is a file that where you mention what you need. So you need Nginx on Alpine operating system, and you want so and so configuration to be done, and you want to open this port number. So these all are the instructions given by you to Docker daemon. So the Docker daemon understands your instructions if you give it in a file or command line. So if you want to run the containers and manage the containers, you will use Docker CLI. Docker CLI for what kind of processes, for what kind of instructions, like this one. To check the Docker processes, to run a container, to check the information. So these are the commands that you directly pass from Docker CLI to Docker daemon. And Docker file, there is one more thing called Docker file. So in this Docker file, you will mention what you want entirely to run a container and also to create an image. So these all things you can mention in a Docker file. So what we understood here, an image is a read only. So you will not write it in the image. Yes, you can write it, but on a custom image that you are creating. So it is a lightweight template that defines what a container will contain. So basically your container contains, it needs an operating system, it needs runtime to run the application code. So these are the main three things mandatory to run a container, to run your deployment, right? So those all things will be defined in a file called Docker file. So a Docker image, it is built in layers. How is it built in layers? So what is the usage of layers here? Okay, so these will understand that in a while. So these layers using Union FS. So what is Union FS? Union FS is a union file system. Uh, this union file system in Docker, it is a technology actually that lets Docker stack multiple folders in the form of layers on top of each other and see them as a single file system. So if you see this diagram, a Docker image, it is built in layers using a technology called Union FS, Union File System. So each instruction you pass in the Docker file, it creates a new image layer. So let us say you have uh, you have given an instruction called from um, RHEL 10. So this is the first instruction in the Docker file. So here, first base image is created, the first layer at the bottom of the file system. So what does it mean? From RHEL 10, meaning it will get from Docker Hub, what it will get? RHEL 10 operating system. Thereafter, you will say, okay, Nginx. So this is Nginx runtime. Another layer is added on top of this RHEL 10. Or you can also mention um, Alpine, any operating system that you want. You want Ubuntu or you want Rocky Linux. So whatever you want. So this becomes the base image on which, on top of which you can create multiple layers. So this image is immutable, meaning once you build the image, it does not change unless and until you manually change it, right? So images are reused to create multiple containers. So with I have created one Nginx image that runs on Alpine or Ubuntu, and I have also copied my application code into that image. But I want to run 5 Nginx servers. With the help of this single image, I can simply run multiple containers. So reusability. You can, once you have created a Docker image, you can create multiple containers out of a single Docker image. So what technology Docker uses for multiple layers of building a Docker image? It is Union FS. So let us come back here. Union FS in Docker is a technology. It is in Docker that lets Docker stack multiple folders or layers on top of each other, and you will see them as these entire layers. It behaves as a single unit, right? It behaves as a single file system. So this entire system, this entire image is a combination of multiple layers. So why Docker needs Union FS? So let us understand why exactly it needs Union FS. Basically, a Docker is built in layers. So as I said, it requires a base layer with operating system, any operating system, on top of which you need to create a layer for runtime. For example, you are deploying Java application. So you need JDK. JDK is a runtime. And for Python runtime and Node application. Runtime layer, any runtime layer on which your application runs. And the third one, application layer, where you will copy your application code. So it may be a WAR file or Python code or Node or even static content like index.html or JSP, index.jsp, whatever, based on your requirement. So on top of runtime layer, you will create application layer, right? Which contains your application code. And finally, configuration layer. So what is this configuration layer? Let us say for Node application or for Nginx, you need to configure few things. For example, httpd.conf for Nginx. So you can create your own configuration on your host operating system, right? Configuration file, and you can push this into the image where you can change the parameters for this entire image. So we'll see these all things in practical lab session. So a Docker image is built on layers. Why? but this is the reason. You are separating each and everything. You are separating the base operating system layer, runtime layer, application layer, and configuration layer. So for example, this entire these three layers are created by a developer and tested. Everything is working fine. So the developer pushes this into Git, commits the code into Git, and the CI/CD pipeline runs, and it will be stored in the registry, right? So Docker Hub. So this image, you want to use it in production environment, so prod. So what you will do, you can pull this image on prod environment, but you want to change few things. So at that time, you can only change the configuration layer. You don't have to touch all these things. So that is why separating these all things is required. And these all things, separating the layers is provided, this feature is provided by Union FS, right? So these all things. For example, let us say maybe you want to deploy or you want to create another image with the same operating system and same runtime, but application is different. So you can reuse these two layers. We'll see this in real time, uh, how the layers are used in production environment. So basically, Union FS merges all these layers into one usable file system inside a container. So what happens when a container runs? Image layers are read-only. So these all are read-only, and Docker adds one read-write layer on the top. So basically, this one or this one. So where you can read and write. Any change you make goes only to the top layer, and these all things remain same. So as I said, in production, you want to do some configuration changes. So you can do changes only in the config layer, and rest of the things will remain same. You don't have to touch it. So original image layers stay untouched. So that is how the consistency across all the environments are maintained. So Union FS in Docker plays a main and crucial role. So this all these layers are read-only, and it behaves as a single file system. All right. So here is an example like Nginx with a base operating system layer and Nginx binaries and configuration files. You will once the image is built, you can run the commands like image, docker pull, docker inspect. So these are the different commands used. So in a real world scenario, your DevOps team builds a base image. What is a base image? This is a base image with OS patches and libraries. So whatever the libraries required for Nginx and this Linux operating system, it is updated with an operating system patches. So this is done by your DevOps team. And developers, they extend it for different applications using Docker files. So these all things are done. Base layer, runtime, these two are done by the DevOps team because building the image is taken care by DevOps engineers. And developer, they can add application layer. So application layer is a read and write layer on top of these two layers. Once the application layer is created and it is given to you to deploy it on either QA or prod, so you can create one more layer to centralize the configuration. Meaning from a single place, you can do all the configuration that is required for the application and application runtime, which is Nginx server to run, right? So these all things. So the first two will be done by DevOps, DevOps team, and this is done by development team, and this will be done by you as an admin, right? So this is how the entire ecosystem, Docker ecosystem works.